All right, in this video, this is T's live session number 11, and in this live session that I did over in my Facebook group, we actually looked at 11 multiple choice problems, as you can see right here on the screen. And this live session lasted well over 1.5 hours. I have edited the video down to where it's right around 1 hour long. But again, 11 problems, they're all different topics. And without further ado, let's go ahead and get started. So, this first thing, I'm going to mute my microphone. I'm going to give you 1 minute and we're going to try to do some operations with mixed numbers. So here's the first question. I'm going to mute myself and let's go ahead and get started. So yes, I only gave you 1 minute to do that question. And even if you are proficient with doing operations with mixed numbers, this can still be tedious and cumbersome because you have to convert, or the way I teach it is I tell them to convert the mixed numbers to improper fractions. And since we are subtracting, we have to get common denominators and all that stuff. Well, I want to show you a multiple choice tip. As a matter of fact, this is the first time I'm showing a group of people except for the mini sessions. When I tutor students individually, I do private tutoring as well. They love this shortcut. This is a huge time saver. So instead of us trying to convert these to improper fractions and then getting common denominators and all that stuff, let's just go ahead and convert these to decimals. This shortcut will work with multiple choice. So this 7 3/5, the 7, I'm just going to bring that down as my whole number. 7 3/5 means 7 point something. And this is a good review. Converting fractions to decimals, take your fraction, 3 divided by 5, 3/5 is 0.6. Don't worry about the 0 up front. This is 7.6. Now bring down your minus. We have 2 5/6. Well, the 2, let's bring it down just like we did with the 7. That's our whole number. And now when you get funky decimals, like this one, 5/6. If I take 5 and I divide it by 6, notice we get a funky decimal. Now, what you don't want to do here, folks, is this. Don't just say 2.8. This shortcut will only work as long as you use enough decimals or enough places to the right of the decimal. So 2.8, and then just write down at least 6 of those digits. In this case, it's an 8 and a bunch of 3s. So therefore, 2 5/6 is 2.8 with a bunch of 3s. Now, if you already see where I'm going with this, I've taken my fractions, my mixed numbers, I've converted them to decimals. Now let's just do the operation with the decimals. 7.6 minus 2.8, and let's just put down some 3s. So 1, 2, one more. You just want to use enough. Use at least 6 digits. If I use more, it's fine. Not that big of a deal. Just don't use too few. So press enter and we get this answer, and let me copy that over. So now that we have this answer, what we can do is we can automatically eliminate some choices. And this is where a lot of people mess up right out the gate. 4 and blah, 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 we can cross out anything that has a 5 as a whole number. And some of y'all may have been thinking, well, 7 minus 2 is 5. Yes, but sometimes think about it. When you subtract, you have to borrow. And we're letting the calculator take care of all of that stuff for us. So we don't want to pick the 5s. Now all we have left to do, folks, is either look at this fraction in yellow or this fraction in green, and let's see which one of these fractions gives us 0.7 with a bunch of 6s, the closest possible decimal we can get. So let's take the first one. The 4 is good. Don't worry about the 4. Let's take the 23, divide by 30, and there it is. Boom, look at that. 0.7 with a bunch of 6s. 0.7 with a bunch of 6s. Whereas if I just come in here and try 19 divided by 30, that green fraction, 19 divided by 30, that's 0.6 with a bunch of 3s. So the one that is the closest here is going to be this 0.76 repeated. That's that 23/30. This shortcut, folks, works with adding, subtracting, multiplying, dividing. If you have order of operations with a bunch of fractions in it, Do it. It's a multiple choice shortcut. Now, I would love to sit here and do this for the next hour to let y'all practice, but that's what I'm going to leave you left to do once you get done with tonight's session. Go back and practice this. Go try my free practice test. Just go type in, go Google random adding mixed numbers, subtracting mixed numbers, and see if you can make your answer, your decimal, match as close as possible to the actual problem. Huge time saver. I definitely understand that. And in all honesty, folks, this is a problem that you cannot afford to miss on the T's. No ifs, ands, or buts about it. These ones you have to get right. So that's number one. Now, what I'm going to do next is I'm going to go ahead and, first of all, I'm going to delete that page. That's going to drive me crazy. But I'm going to go ahead and put the second question up here. I'm going to do a minute, and if you have questions, I'm going to be reviewing the questions as this timer is running. So here's question number 2. This is a basic proportion word problem. All right, folks, so I know somebody said they couldn't hear something. So whenever I got this timer running, again, I want to make this interactive. I want to give you all a little bit of time to actually try these problems out as well. So if you ever see that timer running, I'll have it here in the middle of the screen. You know, that's when you can try this out. Try it out on your own. I know it's only a minute, but it's better than nothing. But I am seeing the answers fly in, and B is going to be correct. So this is a basic proportion problem. A company mass produces keyboards as an accessory for a popular tablet. For every 25 keyboards that are produced, 2 of them are defective. Now, there is more than one way to set up a proportion, and if you've seen my videos or you've heard me talk about proportions, I say that every time. Out of 25 keyboards, 2 of them are defective. Now, even though that number 2 is not written out numerically, it's the number 2. So you can't, don't overlook those words that represent numbers. So it don't matter how you set this up. But since I have these 2 numbers in the same sentence, I'm going to write down my first one, 25, and I'm going to put it over 2. And I bet some of y'all did not set it up like this. Totally fine. You have a lot of freedom with proportions. But what I'm going to do here is I'm going to remind myself, this 25 represents the total number of keyboards, and out of these 25, 2 of them are defective. Now, some of you may have put the 2 up top and the 25 at the bottom. It does not matter. Don't stress out over putting it in the right spot. What's important is that you understand what each number represents. So out of 25 total keyboards, 2 of them are jacked up. Now let's read the rest of the problem. If the company produced 1,300 keyboards, produced 25 keyboards, produced. This 1,300 is not the defective. This 1,300 keyboards is the keyboards that are produced. We want to put that at the top since that's where I put the 25 keyboards. Go back and look at that problem. 25 keyboards produced. I put it at the top. 1,300 keyboards produced. I put it at the top. Now, what does this X truly represent? Without me even reading the rest of the question, so I've mentioned this numerous times as well, do not waste time writing down anything else once you set up your proportion. Look at your 3 numbers, and the number that's going to get multiplied by the X, which is 25, that's going to ultimately end up being the number that you divide by. So we're going to ultimately end up dividing by 25 or whatever number's getting multiplied by X. So from here, I'm going to multiply my 2 times my 1,300. And I know some of us like to write that down. Well, I'm trying to push you away from that to get you back those precious seconds that some of you may need who are running out of time. So 2 times 1,300, 2,600. Don't really care. Let's immediately divide by the 25. That's the number that was with the X. So immediately divide by 25, and bam, there is our 104. That is the correct answer. I saw a lot of B's coming in, and this is what I call a basic proportion problem. You cannot afford to miss these either, folks. I'm going to tell you the ones that you can afford to miss and the ones you can't. The first shortcut I gave you, mixed numbers, we got to get that one. If you have a basic proportion word problem, you got to get that one. Now, I'm going to try to fool you a little bit. You probably wonder what this, see, and a lot, if I had made that the initial question up here, some of y'all probably would have ended up still picking B. And I'm going to tell you, I'm going to get you tonight. I'm going to try to get you tonight on some of these questions with the wording. So for this one, if this was the question, how many are expected to be working properly out of those 1,300? Well, what we could do, I mean, you could still solve it like this, but we would want to take that 1,300 total keyboards and subtract the 104 that are jacked up, leaving us with 1,196. And like I said, I'm going to try to get y'all tonight with the wording. You have to be careful, okay? All right, fantastic. So, yeah, that's number 2. Now, based on the topics for tonight, that was a basic one. Here comes a multi-step proportion word problem. Multi-step. This one's tricky. I wish I could give you longer than a minute, but folks, we got a lot of questions to cover. So I'm going to go ahead and pop up number 3. Let's go ahead and give this a shot. And again, I'm about to run the timer, so I will be quiet during this time. I do see one answer coming in, D, and that's for number 3. Nice job. Oh, D, you got some more D's coming in. Fantastic. You all did that in under a minute. That's good. Now, I know this one is tricky, though. Now, I'm going to show you 2 ways. So let's go ahead and clear the air there. I'm going to show you 2 ways. The first way is the fast way. This is how I would do it if I wasn't teaching somebody, but I'm still going to show it to y'all anyway. I see 15-page research paper. I'm going to break this up piece by piece. I see a 15-page research paper, and there's 750 words per page. Before I even read anything else, I'm going to go ahead and probably tell myself, hey, I likely need to multiply here. So 15 times 750. Now, what is this going to tell us? 15 times 750. This is going to tell us the total number of words in that entire research paper. There's 15 pages, 750 words per page. So again, 15 pages times 750 words per page, 11,250 words. That's the total number of words that Seth is going to have to type. Now, if Seth types at an goes by, Seth is typing 90 words. He's a pretty quick typer. 11,250 words. So it's going to take him much longer than 1 minute. It's going to take him many minutes. Now, the quick way, fast way, I would take the total number of words, 11,250, and let's divide it by how many words he can type per minute. Divide that by 90. So 11,250 divide by 90, we get 125. So this 125, what does this really represent? And again, this is the fast way. I'm going to show you another way right here in a second. If his total essay is 11,250 words and he types 90 words per minute, it will take him 125 minutes to type the essay. Now, he started typing the paper at 10:30. So it's going to take him an additional 125 minutes after 10:30 to finish this paper. And that's what we're trying to find. So basically we're saying, okay, the time is 10:30. What time will it be in 125 minutes? Well, something that comes to mind for me, again, fast way, is I see this as being 1 hour, another hour. Notice I'm doing minutes. 60 minutes, 120. There's 120 minutes in 2 hours, but then we got that 5 additional minutes. So the way I'm seeing it is I see it as 2 hours and 5 minutes. That is 125 minutes. So the time's currently 10:30. We have to go 2 additional hours. So that'll be 11:30, 12:30. So think about this, 10:30 plus 2 hours. That's going to be 12:30. And not only that, it's going to be 12:30 p.m. And then we got that additional 5 minutes. So plus those additional 5 minutes right here, that's going to be 12:35 p.m. So a multi-step. That's why this answer is D. Now, I'm looking through, some people, not knowing where to start. I totally understand. These are the multi-steps. And I want y'all to think about what I've done here. And again, I'm recording this video. You can go back and watch this. But I'm breaking it up piece by piece. And that's what you have to really do when you're practicing word problems. Don't look at it as one big old clump of stuff. No, you want to break it up into pieces. So I do want to show y'all another way. So this is the fast way. Again, I didn't write down many words. I just did a whole bunch of number crunching. And if you followed that, fantastic. If you didn't, hey, I want to show you another way. This always works. I'm going to show you multiple proportions, and this will get 90 words per 1 minute. Another proportion. This will work. So, what do we know? There's a total of 11,250 words, and we have to figure out the number of minutes. Well, cross, multiply, and divide, folks. 1 times 11,250, well, that's just going to be 11,250. Immediately divide by 90. Immediately divide by 90. And if I do that, check it out, folks. We're still getting the same time here because that's what we're solving for in this proportion. So x equals 125, and this does represent minutes. And I see that, like, people are saying, I like the proportion way. Yes, and the proportions are there. You can do a good chunk, not all of the questions, but you can do a good chunk of the questions on the math portion of the T's using just proportions. And then from here, I see some of y'all saying, hey, we could take 125 minutes and divide it by 60. Sure, you can do that to get the number of hours and minutes, but that leads to funky decimals. There are ways to work around it. But I hope that right there kind of made some sense too. Taking 125 minutes and breaking it up into 60-minute increments, which is 2 hours, because we have 2 of those, plus that 5 additional minutes. So many ways to do this problem. But that's what I would call a multi-step proportion word problem. There are other ways of doing this. This is just one of many. I could sit here and talk for 30 minutes about this problem, but I'm not going to do that. But yeah, so that's the proportion piece. Now, ratios can be tied into proportions as well. So the next 2 problems we're going to look at, a basic ratio word problem and a tricky ratio word problem. And then we'll actually come back in number 6 and we'll do a rectangles and ratio word problem as well. So ratios is going to be our next little chunk of problems that we're going to work on. And speaking of, let's go ahead and do number 4. 1 minute, give it a shot. All right, so I told you I was going to get you. Before I dive into this problem, so a comment came in. Breaking up a word problem is so much easier than trying to understand it as a whole. I couldn't say it better. That's the way I've always tackled word problems when I do it. That's the way I teach it. I break it up into pieces. So now for number 4, I'm seeing various different answers coming in. I'm seeing some A's, some C's, and some D's for number 4. So let's see what the correct answer is here. There are 36 boys in a class of 78 students. 36 boys, 78 students. What is the ratio of girls to boys? So you have to read it carefully. We want girls to boys. So I want G to B. The order does matter with ratios. The word to is where we can put our colon, or sometimes you may even see a fraction bar. So girls to boys. Well, how many girls do we got? We don't know yet, do we? This is where you have to read the question a little bit more carefully. We know we got 36 boys, 78 students in all. Let's find the difference. Let's subtract there. And we'll get 42. So there's 42 girls in this class. That's going to be my first number. Whoops, and I'm writing the word girls again. 42 girls, and then colon, 2 girls, 2 boys. Well, we were told there were 36 boys to begin with. So 36 boys. This is our ratio, 42 over 36. Now from here, I did mention you can either see a ratio written with a colon in between it, or you can see it written as a fraction. So we would put the girls up top since that's the first word, boys down here. And you could grab your calculator right now. You could. I'm going to go ahead and show that to you. Here's calculator shortcut. 42 divided by 36. I'm looking for this decimal. This decimal. 42 divided by 36 is 1.16 repeated. Go through here and take your first number divided by your second number. Do that for all of these. And the only one that's going to work is D. Look, if I take 7 divided by 6, 7 divided by 6, boom, same thing. And you might say, okay, well, I didn't do the calculator way. That's where simplifying comes into play. A common factor for 42 and 36 is 6. 6 goes into both of these numbers. As a matter of fact, it's called the greatest common factor. 42 divided by 6 is 7. 36 divided by 6 is 6. Bam, same thing. Now, for some of these other ones up here, like I think this right here, this would be, if I'm not mistaken, that was the ratio of boys to the entire class. I don't know, I'm having to, let me see, 36 divided by 78. Yeah, that right there, A is not the correct answer. A would be the ratio of boys to the total number of students. This ratio right here would be the ratio of the total number of students to the boys. You have to make sure you're answering the question that you're being asked. This ratio right here would be the ratio of boys to girls, but we wanted girls to boys. The order is important. And here's one that's slightly more trickier. This is going to be number 5. Go ahead and have a look at that. I did see a comment where, I told y'all I'm going to try to trick you. And really what it boils down to, folks, is I just want to make sure you're reading these questions as carefully as possible. So to this problem here, let me grab, where'd my pen go? Oh, there it is. So the ratio of males to females, boom, ratio, males to females. So 7 represents males to females. Now, what does this mean? Males, 7 males. I'm going to actually kind of do a picture here. 3, 4, 5, 6, 7. What this means visually, I want you to imagine these M's representing 7 males. And for every 7 males, we're going to have 8 females. So 7 males for every 8 females. Now, you don't have time to do this on the tease test. I'm going to go on and tell you. How many people do we have right here? There's 15 people. And the reason why I'm mentioning that is because I want us to think about this as being like the total. For every 15 people we have, 7 of those people, 1, 2, 3, 4, 5, 6, 7, make sure I did that right. 7 of them will be males, 8 of them will be females, for a total of 15 people. Now, obviously, we have more than 15 people at this conference. There's 210 people at this conference. Well, notice that is a total. That is not just males. That is not just females. That's the total number of people, which is why I'm trying to tie in a total into my ratio. Now, if there are a total of 210 people at the conference, how many females are there? Well, what do we know about this little visual picture I showed you here? There are 8 out of 15. Let's make sure we understand that. Let's write down what each one of these represents. The 8 represents 8 females out of every 15 people. So out of a total of 15 people, 8 of them are females. And since up here, 7 males for every 8 females, that you can just add those together to get your total for that particular piece. Now, let's read the question. We're trying to find out how many females there are. There's a total of 210, so we want to put that at the bottom to match up with our proportion. And the reason why I did pick 8, well, 8 is the number of females, and we're trying to find out how many females there are. So therefore, this is why I'm gonna put my X up here. 8 females out of 15 people is equal to how many females out of a total of 210. And this is going back to us cross multiplying and dividing. And I don't know why my calculator is going behind the screen, but anyway, so let's just cross multiply. 8 times 210. Don't really care what I get there. Let's immediately divide by 15. And there we go. We get 112. There's 112 females at that conference. Our correct answer is D. Now, sometimes you don't have to do this whole 7 plus 8 gives you 15. I mean, I had to do that in this case because the 7 represented just males, the 8 represented just females. So to find a total, because I had a total in this problem, yes, we do have to add the males plus the females to get 15 people. And the only reason I did that is because this problem was talking about a total number of people at the conference. So a slightly trickier ratio problem, and we're going to continue on, but we're going to do a little segue into geometry. But this first geometry problem here is going to still deal with ratios. And by the way, a lot of these questions is based off of me asking you all in the group, what did y'all want to see? And a lot of people were saying ratios, multi-step problems. Quick question was, how did I get 112? We're solving this proportion here as fast as possible. So let's do that one more time, making sure we're all on the same page. I'm going to take that 8 times 210. 8 times 210. Don't even write that number down. We don't want to waste time on that because we don't want to lose or run out of time on the t's. Let's immediately divide by the number that's with the x. The number that's going to get cross multiplied by the x is 15. So let's immediately divide by 15, and that is where that 112 comes from. There's 15 folks right here. All right, here we go. Y'all ready for this? I know this is crazy, but this does allow you to see it visually. So what I've done here, and let me just double check one more time. So if I take 15 people in one row times 14, we get 210. There's our 210 people. And notice what I did here too, is that for every time I copied this row over, I kept the same ratio. For every 7 males that I put down, I have 8 females. Now, you don't want to do this on the T's test, but it does say how many females are there. Well, look at how many females we have in each row. We have 8 in each row, so 8 per row times 14 rows, and we're going to go right back to that 112. This is crazy doing it this way, the visual approach. You would clearly run out of time. So let's move on to geometry, and this is a ratio problem. Give you 1 minute to try it. Give it a shot. All right, so for this problem, before I dive into this one, I was just kind of reviewing over the comments. You know, earlier in the night when I was going over the mixed numbers, that basic proportion problem, I mentioned those are ones you cannot afford to miss. Folks, don't beat yourself up if you can't get every single one of these questions. I mean, very rarely do we see people getting 100 on the T's test because they encounter problems they cannot solve. So, I mean, like, yeah, that last problem, that's a tough one. That's a tough one. And that's where most of the questions came in. Don't let that one question frustrate you. I know that's easier said than done, but that is one that, hey, a lot of people probably would miss something like that. Now for this question here, you know, we're hitting ratios really hard. The ratio of the length to the width of a rectangle is 5:3. So I mean, in all honesty, you don't even have to put the length and the width, but remember the other way I said we could write this, 5:3. We could write it as a fraction. And we can go ahead and take this fraction and we can convert it to a decimal. 5 divided by 3, we get 1 point with a bunch of 6s. So that one right there, daggone it, and why does it keep going to another page? So 5 over 3. Now, this is just one way that you can do it, but what we want to do is we want to look and see, hey, if I take the big number 5 divided by the little number 3, that's exactly what I did here. Let's do it over here for all these. Take the big divided by the big divided by the little, and the only one that's not going to work, I mean, I'll go ahead and do them all anyway. 25 divided by 15. Notice we get the same ratio. Let's take the 30 divided by 18. 30 divided by 18, we get that same decimal. It's the same ratio. Look at C. 35 divided by 24. Ooh, look at that one. That one does not give us the same decimal. Whereas if we take the 55, big divided by small, we do get the same ratio. So it turns out the 35 over 24 is the one that does not work. And the question does say which one could not be the dimensions of this rectangle. And just to show y'all another way too, folks, because we do need to know how to simplify fractions, even though we have these shortcuts. Watch this. If I take 25 over 15, I'm taking, just like here, big over small, big over small, big over small. If we simplify this fraction, this is what it really boils down to, folks. 25 divided by 5 is 5. 15 divided by 5 is 3. Same ratio. This one here, 30 over 18. You can divide these by 2. You can divide them by 3. I'm going to divide them by 6. That's the greatest common factor. So 30 divided by 6 is 5. 18 divided by 6 is 3. Look at this. We're getting the same exact fraction, the same ratio. It actually turns out 35 and 24, they don't even have a common factor, I don't think. No, we cannot. That's, if we write this fraction right here, 35 over 24, not going to happen. You cannot simplify that anymore. Whereas this last one here, 55 over 33, I love these double digits. You can divide these by 11. That was one of the first times tables I remember learning many, many moons ago, other than the ones tables and the twos tables. But dividing those, we get 5 over 3. So as you can see, all of these, taking the big divided by small, we get the same ratio with the exception of C. This is the one that cannot be the dimensions of the rectangle. So I am seeing a lot of comments coming in. So we got some answers. Hopefully we do see why D does work, but C does not work. Are you allowed to use a calculator? Yes. Calculator, yes, on the entire TEAS test. So anytime you have a fraction, you don't know what to do with it, grab your calculator and do the division. All right, so that's number 6. Let's go ahead and proceed forward with number 7. So, well, I think for the most part, we're done with ratios, proportions. Now we're going to move into a little bit of geometry and ultimately get into some percentages and graphs. Try this one out. All right, so number 7. For a rectangle. So it says the length of a rectangle is 24 feet. All right. So, I mean, you have time to draw down a quick rectangle. And that's what I'm going to do here. And it says the length is 24 feet. I haven't read anything else yet. Yeah, you might skim it over. But a lot of times when I do word problems, I just go ahead and start brainstorming right off the bat. Sometimes it helps, sometimes it doesn't. But rectangle, I got 24 on opposite sides. Now look at this next thing. The perimeter of this rectangle is 78 feet, and our goal is to find the area. Do not, just because you see 2 numbers in this problem does not mean you want to multiply 24 times 78. Notice that answer is up there. No. The formula for the area of a rectangle is length times width. That's never going to change, and that's a formula that you definitely want to know. So length times width. We're trying to find the area. We got to know the length. Well, the length we do know. The length is 24, but we don't know the width. That's the big question mark here. What in the heck is our width? It's not 78. 78 is the perimeter. So let's pay attention to this. The perimeter of something. If you think about like a security guard working at a facility or working at a prison or something, if they walk around the perimeter of that facility, they walk around the edge of that facility. So the perimeter is the distance around a shape. You add up the sides. That's how you find perimeter. So you might say, okay, the distance all the way around is 78 feet. Well, folks, we need to use the lengths that we have here. This much across here is 24, and then when we come down here, that's going to be another 24. 24 and 24, those two sides together give us 48 feet already. Now, the entire distance around this thing is 78. So we already know with the two lengths that we have, that's going to cover 48 of those 78 feet. Let's subtract off our 48. 78 minus 48, we get 30. What does this 30 represent? We have 30 feet left to go around this rectangle. 30 feet left to go around this rectangle. Do not take that 30 and put it on both sides. Because if you add them up, that's going to give you more than 78. You have to take that 30 and you got to divide it by 2, folks. 30 divided by 2, we have 15 on each side. So 15, 15. And let's just double check. Take 24 plus 15 plus 24 plus 15. I'm adding up all 4 sides and I get 78 feet. Now, we see 15 up here as an answer. You have to make sure you read the question. The question doesn't say what is the length, or excuse me, the question does not say what is the width. The question says what is the area. Well, we had to find that width. We found it to be 15, and now finally we can take our length times that width that we found, 24 times 15. This will here. Yes, the answers are flying in. D is correct, no doubt about it. So that's good, but I want to go through this and I want to explain why you can't. It's fine. Probably what majority of you all did. Y'all probably found 60%, and this is right, by the way, 60% of $75. But that's what this problem is really saying here. He sold it a week later at a price that was 60% more than what he paid. Well, he paid $75 for this piece of furniture. So if he sold it for 60% more than that, first of all, we got to find 60% of that price that he paid. And we know this price. This is what he paid. Now, I'm emphasizing this for a reason. So now you can use proportions, but I mean, if you have a percentage and you know what you need to take the percentage of, just go ahead and do 60%. You can do 0.6 or 0.60. Let me write this down. 60% is 0.60 or 0.6 of the price he paid, 75. So if we find this, 60% of 75, 45 bucks technically represents the profit he made, if you want to think about it like that. Notice that answer choice is up here. The question didn't say how much profit did he make. If the question said how much profit did he make, boom. If the question had said how much more did he sell it for, he sold it for $45 more than what he paid for it. But the question does say how much did he sell the piece of furniture for. Take the price he paid plus that markup, so to speak. He marked it up 60%. He marked it up an additional $45 because 45 is 60% of 75. You add these together, he sold it for 120 bucks. Our answer is D. So this is what I would call, somewhat of a basic percentage problem, because we're given a percentage and we're given the number, that $75. We wanted to find 60% of that because that's what he paid. Now I'm going to try to get you on this one. All right. So number 9, let's have a look at this. Give it a shot. All right. So I did this on purpose because maybe some of y'all noticed that this is pretty much the same problem, except we're kind of like working backwards. Now, I'm going to write down an equation, and then I'm going to talk about this whole markup deal. So, Pedro purchased an antique piece of furniture at an auction. he sold it a week later for 120 bucks. So that does not tell us how much he paid. This tells us how much he sold it for. Now, talking about this represents a 60% markup over what he originally paid. So when we find, this is what you don't want to do, and this is one that you can afford to miss, but I still want to explain it. 60% markup over what he originally paid. This is not what he originally paid. You do not want to find 60% of 100 what it is. Now, we could go through our multiple choice answers and work it out, but watch this. So, Pedro paid X dollars. He paid X dollars for this piece of furniture. Now, what is he going to do? So this is Pedro's price or original price. But what is he going to do? He's going to mark it up. Well, for him to mark it up, we have to add on the markup. Now, hang with me. So the markup, that's an ugly R, but it is what it is. So this is the markup. Well, how do we figure out the markup? The markup is going to be, so if we take the original price plus the markup, we're going to get the 120 that he sold it for. Now, with these markup problems, if you're trying to find the original price, here's how it boils down to it. We have an understood 1 in front of this X plus 0.6x. If we combine like terms here, we get 1.6x equals 120. Now, where does this 1.6 really come from? If you think about it, he's marking it up 60% over what he paid. The 1, understood 1, just did this problem. Pedro got a good hustle going. Remember this 75 from the problem before? This was the original. Exactly what I'm writing down here. The original plus the markup. But in this particular problem, folks, we didn't know the original. Back here, we did know the original. I hope you do see, even though, yes, these problems are asking different things, we are still taking the original. Here, we did not know what it was. We're still adding on the markup. And how do you find that markup? How did we find $45, y'all? How did we find this $45? Look, we found 60% of what? 60% of what he originally paid. You see that? That's exactly what this is saying. 60% of what he originally paid. That is the markup. We combine like terms. And here's a shortcut if you run across a markup problem like this, is if it was a 40% markup, it would end up being 1.4 down here instead of 1.6. If it was a 20% markup, it would have ended up being 1.2 instead of 1.6. If it was a 35% markup, it would have been 1.35 down here. So I'm trying to show you a spot, if you will, where you can just essentially take that percentage and set up an equation by just putting a 1 in front of it. That's one way that you can tackle markup problems, but you have to be careful with the wording. But again, this is a problem that you can afford to miss. So I know these get people a lot. If we did find 60% of 120, that is not correct because we don't want 60% of the price he sold it for. But if you did that, you would get 72, and notice that answer choice is up here as well, and that is not correct. Now, to the multiple choice answers. This is what, if we can realize that it's a trick question, so to speak, sure, what you can do is come here and find 60% of 75. We did this in number 8, and what did we get here? 45 bucks. And notice if you take the original price that we're trying to find, 75, plus the markup of 45, you go right back to your 120. These are the tough problems to teach for the T's. So that's your multiple choice tip there. Yeah, just go through your answers and find 60% of each one. Make sure to add on that markup and boom. And I mean, that's exactly what we did back here, folks. I hope y'all realize that. I hope y'all see, even though these two problems are different, I'm trying to show you a relationship between them. And I totally understand. I see Brittany saying it gets me every time, and you are not alone. A lot of people, they just want to automatically multiply a percentage by whatever number they see, and unfortunately, we cannot do that. That's not the correct way to do it mathematically. But let's move on. We got 2 problems left. These are going to be involving pie charts, and it's a little segue going from percentages. We're still talking about percentages, but now we're dealing with interpreting graphs. So 1 minute, give it a shot. All right, so answers flying in. I'm seeing some B's and some D's. Now, so we got a percentage, pie chart or bar graph. You can interpret these either way. I mean, essentially a pie chart and a bar graph have a lot in common. If we find 32%, 0.32 times 600, this gives us 192 students. So 192 students is the number of students that did choose math as their favorite subject, but this says did not choose. So therefore, 600 students in all minus the 192 that did choose it, and now we will have our final answer here. Tricky. I know. I'm just trying to get y'all to pay attention to those words. That's what I'm after here. So 408 is our answer. Now, what I want to show you all is maybe another way that some of you did this. Since we don't want math, did not choose math, check this out. I'm going to ignore the 32%, but instead I'm going to look at those that picked history, English, and science. Basically, this should be the difference between 100% minus the 32%. And that's going to give us what, 68? So what does this represent? Since 32% did pick math, if you add up 20 plus 18 plus 30, you will get the remaining 68% that did not choose math. So therefore, if we find 68% of the total of the whole, 68%, 0.68 of 600, boom, we go straight to our answer. So 408. So, 2 different ways of approaching it. And I am seeing in the comments that some of y'all actually did this way. Perfect. Fantastic. Now, you can do proportions, but I know what I'm hearing about a lot of people too. People are scoring in the 70s and they're running out of time, which means you know how to do it. You just need to figure out faster ways. And as this video as I edit it and I upload it and more people watch it, that's something else I want to stress here in this live session. Not only to be careful with the wording, but also try to find faster ways. I know proportions are great, but sometimes we got to have faster ways so that we can finish the test in time. All right, now one more problem, then we'll do a giveaway. And folks, I don't know if I put this up here, but there is an important announcement. Some of y'all probably already know what's coming, but we're gonna do number 11, we're gonna do the giveaway, and then we're gonna do an important announcement as well. So this is the last math problem. Give it a shot. But now this last one here. So what we're doing, first of all, we got to read it carefully. So 86 people represents the second highest. That right there, second highest. Which one's the second highest? The second highest is going to be the hamburger folks. And this represents 20% of the people surveyed. However, this 86 is not the entire number of people. The 86 is just this portion right here. Various ways you can do this, folks. One way we can do it, since these represent our whole, it says how many people were surveyed. Whereas in this previous problem, we were told the number of people who were surveyed. So one way you can do this is you can go and find 20%, because we're talking about the second highest. So if you miss that second highest, then you're already looking at a different percentage. But the 20% is the second highest. So this is one way you can do it super quick. Just go and find 20% of all of these totals. And sorry about the pen, but I'm just multiplying them all by 20%. And if we do choice C, if we take 20% of the total, 430 people, look at what we get. We get 86. So using those answer choices, the multiple choice tips, and again, why am I multiplying these? These numbers represent the whole, the total number of people surveyed. You do not, this is going back to that percentage thing, do not find 20% of 86. No. Actually, what you want to do, if you want me to show you this, instead of us multiplying by 20%, guess what we do, folks? Instead of multiplying by 20%, we divide. That's all we have to do. 86 divided by 20%, bam. And that's what gets people. They always think they're supposed to multiply a percentage by a number. And the only time you really want to do that in situations like this, the only time you want to multiply a percentage by a number is when that number represents the whole. This 86 is not the whole. This 86 is a portion. So take the portion and divide by the percentage. That will give you the whole. Very common misconception there, but yeah, your multiple choice tip. Yeah, I hope you found some of this stuff useful, folks. Proportions work by all means. We could have done this, and I'll kind of end on that. 86 is the portion out of the whole that we don't know. Over 100. Cross, multiply, and divide. 86 times 100 divided by 20, and boom, we get 430. So many ways to do this. I totally understand. Folks, I got something I want to talk about. Maybe you've heard about this, maybe you haven't, but it's already kind of spreading like wildfire, so I'm going to talk about it anyway. But let me pull up these two links right here. All of this stuff that I have wrote down tonight, folks, I am going to save this. I'm going to add it to the group so you can immediately have access to all of these notes. Give me a few days to please edit the video and get all this stuff uploaded. But folks, these two links right here will be in the notes. I'm just going to copy this over and I'm just going to let you read it. Some of y'all probably already know what's coming. But if you are testing, you still got about, I'd probably say a little less than a year. I don't know the exact time frame. I don't work for ATI. This is 2 colleges that are starting to advertise this. T7. This, I don't know where this college is, but this is what's been traveling around. ATI is going to be doing a TEAS version 7. I was here back when TEAS 5, well, I wasn't here on Facebook, but I was teaching TEAS classes back during the TEAS 5 a lot. They changed a certain number of questions, but it wasn't like an entirely different curriculum. And I don't know what's going to happen with the English or the science, but I can tell you this. God willing, I'm not going anywhere. So some of y'all are probably going to end up taking the version 6 test anyway, which is fine. But when 7 comes out, guess what? I'm going to be on top of it. I'm going to make sure whatever content I have available is going to be relevant to that new version of the test. I'm not going anywhere. Just because a new version of the TEAS is coming out does not mean I'm going to stop doing what I'm doing. Math does not change much. So whatever changes are going to happen with the math, just, you know, stay with me. I mean, the majority of y'all are probably already going to have the test behind you, but I'm also talking about this now for folks who are watching this video. Maybe it's June, July, August, September, or October when the T7 is going to start surfacing in some schools. So there was 2 links. This school here, Saddleback College, you know, they're talking about it as well. October version 7 of the TEAS. Folks, for math, if you're going to be testing around that time, if you don't get a chance to take the 6 and you take the 7, I promise you I'm going to do the best that I can to keep all of my content relevant. But that was the announcement. So if you didn't know about it, it's on colleges' websites. Otherwise, I wasn't going to talk about it. But if colleges are putting it up on their website, then I'm just going to go ahead and be as transparent as possible about it. So there you go. Again, thank you all so much. And I will be talking to all of you in the group. Have a great weekend. Good night.